So I am still seeing some confusion on the difference between mass and weight. So mass, right? We have the units kilograms. Okay, so it's pretty big difference, excuse me. Can never be negative, which means that it's a scalar, right? Because scalars only have magnitudes, and we know when it's a magnitude, that means there can never be a minus sign, indicating no direction component. So this value will never change based on uh, an object's location. Okay, so what that means is if I'm on the moon and I am 150 kilograms. If I go to the moon, I'm still gonna be 150 kilograms. So what I am on Earth, I will be the same on the moon. I'll be the same at Jupiter. I'll be the same at any other planet in the solar system. Okay, or in the universe rather. All right, now if we talk about weight, we know that its units are newtons because it is a force, right? So is a force, and we know that force to be Fg. It can be negative, right? Because that negative for us means that it indicates direction. So that means it is a vector quantity. Um, and this value will vary based on the location, right? So think of moon versus Earth. How we acquire weight is we do Fg equals mg. So g on the moon is 1.6 meters per second squared, whereas g on Earth is 9.81 meters per second squared. I'm obviously going to be a lot heavier on Earth than I would be on the moon. So the moon, I'll be lighter, and then on Earth, I would be heavier. Okay? So mass won't change, weight will change. Weight is a force, mass clearly is not. Mass has units of kilograms, and weight has the units of newtons. Okay? And then finally, this is just kind of a review on coefficient of friction. So if I have a bigger coefficient of friction, that means that I'm going to have bigger amount of friction going on. Okay? So if mu increases, then the force of friction is also going to increase. So that's pretty much the relationship that we're trying to get out here. That should make sense, because we know that mu can only be between 0 and 1, and 0 is essentially frictionless, and then 1 would be really hard to move. Okay? So if I'm closer to 1, that means I'm going to be experiencing a lot of friction. If I'm closer to 0, I would be able to move very easily. Okay, so how would you find the coefficient of friction? All right, so we know that FF equals mu Fn, but what they want to know is how would we get mu by itself? So all you'd have to do is divide the normal force on both sides, and then you get the following. Mu equals FF over Fn, and this supports why mu has no units, because if I have the same thing on the numerator as I do the denominator, they just cancel out, and that's how we end up with a naked number here. So that just means no units. Okay? One last thing in terms of the coefficient of friction. So COF. If you see specific materials in the word problem, okay, I'll give you an example, right? If like wood or copper or snow or ice, rubber, asphalt, concrete, and Teflon, or anything of that nature, see page 1 of your reference table. Okay? There is a chart there that is going to help you out, and it is called Approximate Coefficients of Friction. Okay? This chart is your best friend, okay? It will help you out, so please make use of it. It is on page 1 at the bottom right-hand corner. If you know how to do all of this, then you are set for success on Tuesday's test. If not, please head to tutoring.